Hi everyone, I'm Stephen and welcome to Audio Nautica. So I've got something new turned up from the courier today. This is a Tektronix TM5006 mainframe. I did get it on eBay, and I got this because I'm wanting to expand my test equipment. Now these mainframes are a bit dangerous in that they bring a temptation to collect lots of plugins. Currently I don't have any plugins, but I do have a power supply on order. Now the problem with this kind of stuff is there's not that many of them really available here in Australia. There's quite a few in the States. You usually end up paying just as much for the freight as you pay for the unit itself, which is a real pain. So this one is not perfect. I got it because the price was right. The unit itself was not expensive, but the seller does say that it works, but more to the point, the freight was not expensive. I mean, some of these things, you're looking at $300 just in freight. So this one was shipped via a global shipping program. I think it was about $150 or something like that for the freight, which would probably make people stateside fall off their chairs that I paid that much, but it's either that or nothing if you want to get one of these things. So it is missing a foot, which is why it's sitting funny. I knew that when I got it. Some bits of plastic have broken off in transit. It probably wasn't as packed quite as well as it could be. So, but it is quite nice. I mean, the bit that I'll be looking at, some of them have got gouges and scrapes and stuff around this front bezel. So the front bezel is quite nice. The text is clear. The Tektronix logo hasn't really been damaged. So the bit that I'm going to see will look quite nice. Let's turn it around and have a look at the back. Okay, so here we are looking at the back. Now, I don't know what you call these things, but whatever it is, it looks like it's taken a hit here and this has been damaged. So that's where this bit of plastic has come from. It goes there somehow. There's another bit of plastic. I'm not sure where that's come from, and something rattles around inside when I pick it up, but that's okay because I need to check it out. The first thing I'm going to do is take out the fuse, because this is wired for USA. So just to prevent any accidents, I'll pull the fuse out now, and now we'll get the covers off and have a look at what we find when we look inside. But just before we do that, yeah, it's looking quite nice on the back as well, quite clean. Doesn't have the coax options, doesn't matter, I'm not going to be using any of that. And so yeah, let's get the cover off and see what we find. Okay, so it had definitely taken a big hit on this corner. It's probably been dropped, I would say. It was wrapped in multiple layers of thick bubble wrap, but that's really not good enough. You got to pack this thing in solid foam sheeting if you're going to send it across the world. So you can see this screw has actually been bent. So yeah, it took a bit of effort to get that out. So the screw has been bent, it's been hit so hard, and it's also damaged the hole that the screw goes into. So anyway, if you know where I can pick up some replacements of these, I guess they're feet, please let me know down in the comments where I can get some of these from. And also, if you know where I can get the missing foot that goes on the bottom. Now it's not a biggie if I can't, because I'll just kind of chock the thing up. It's not going to go anywhere, but I'll just turn it over so we can see. That foot there. I think they're all the same. I think it just goes around the other way. So the one up here is missing the foot. So if you know where I can get one of those, please let me know down in the comments. So let's put it back upright. Oops. Yeah, I'm going to want to chock that, aren't I? It's quite annoying. Anyway, let's have a look down here. So I haven't cheated and peeked. This is my first look inside. And the panels themselves are in nice condition. They're not full of scratches and gouges, so that's good. That's pretty clean actually. There's no dust in that at all. Either it's been kept in a very clean environment or the seller has cleaned it. Now the seller did say guaranteed to work, so that is encouraging. But yeah, that's really is quite clean indeed. I can't see any. PCB looks clean, can't see any dust. So that's really, really nice. Okay, so I need to adjust the voltage so that it's set for 240. So this is the this is from the service manual, which is a little bit confusing, black and white, hard to see what's going on. But when you look at the actual unit itself, it's pretty clear. So down there are two like little jumper jigs. I'm sure that's a technical term. And they have to be moved, well, one of them's got to be moved into the 230 volt position. Currently it's in the 110 volt or the 115 volt position. So let's see if I can grab hold of the thing. Oh yeah, that's actually easier than I thought. So there it is, that's all it is. And I just need to put that now. It's probably going to be harder than getting it outwards. The good news is the other one doesn't have to move. But this one, oh, now how am I going to do this? I'll try the good old forceps and see if that will work. If I grab the body of it like so, aha, that felt good. Okay, so now that's on 230 volts, and the other one is to set whether it's high, medium or low, so whether it's 240, 220 or 200. It's already in the high position, so I don't need to move that. So I'll just have a double check with the camera out of the way because I can't get the Maggie lamp close enough, but theoretically that should be in the right position. Also too, the old shake, rattle and roll test, there seems to be a screw or something rolling around inside. I haven't found it yet. I think it's over here somewhere underneath this transformer, so no doubt it'll pop out at some point. Also, I found this sticker inside which says it was last calibrated in 1995, so there you go. Okay, so I do not have the correct value of the fuse, so I'll need to get one of those in. Also, my rattling screw, which I think is under there somewhere, I'm not going to get those panels off to be able to get under there. This one will come off, but I think it's down there, so I'm going to have to resort to the old shake it until it comes out trick. Let's hope this works. Okay guys, I'm very relieved because I've been shaking this thing like crazy and could not find my rattling screw, but can you see where it is? It's jammed in between two wires. No, that's not long enough. which is why it stopped rattling. So I just need to find something. Gee, I hate it when I put tools away. Right. Stay. Just enough magnetism in that screwdriver to get that guy. Right, there it is. So the trick now will be to see if I can work out where this comes from. Anyway, I'm glad I got that out. Okay, well, as soon as I pressed the stop button, I worked it out. It comes from right there. You can see the top of these ones they're all along the top there. So one of them has fallen out, so it should be pretty easy to pop him back in, and I'll just give the other one to tighten up while I'm at it. Okay, so that screw is in. I'd always wondered when this Imperial socket set was going to come in handy, so it finally has. So these are holding in the GPIB connectors. One of them's actually damaged, so this one here, the threaded insert on the connector itself is damaged, but it doesn't really matter. It's not going to go anywhere, I don't think, and I could actually rip all of these out because I'm not going to use the GPIB. I don't think I ever used GPIB once as a professional engineer. But this was one of the features of the TM5000 series over the 500 series, was that it added GPIB. I got this not because of the GPIB, but because I just thought it would be nice to be able to use the 5000 series modules. They're a bit more modern. So you can use the 500 series modules in this mainframe, as well as obviously the 5000 series, but you cannot use the 5000 series modules in a 500 series mainframe. So that's that little problem fixed, which is nice. Now, so the next thing will be checking these capacitors. So this unit has not been cleaned, by the way, because there's a few places where I can see dust, which I'll just get out. But it's just obviously come from a very, very clean working environment, which is really nice. But it is, yeah, really nice clean condition inside. I can't see any evidence of the capacitors leaking. What I'm probably going to do, I don't believe in replacing capacitors just for the heck of it, but they do need to be tested. So I'm going to pull these out. I mean, this unit was probably built, there's a date code on this transformer here, 1984, 8428. So this was built in 1984. So it's 37 years old, and that does need to be taken into account. So I'm going to check all of these electrolytic capacitors, and the other thing that needs to be checked is these are the pass transistors. So there's 4 channels there. There's one more channel is down there, so there's one transistor there, one transistor there, and then over this side we can see those big TO3s there. Those are for the high power rack or slot, which is this slot here, which would be the right hand slot as you're looking at the front of the unit. So again, this was one of the reasons why I got the 6-channel mainframe, because the 5006 supports the high power slots, which means that I can get a dual tracking power supply that will go in there and give me 1 amp of output, I believe. So there we go. Okay, so I've got one of these main filter caps out. It's this lovely looking Sprague 11,000 microfarad 200 volt DC. I mean, it looks as good as the day it was made, basically, even though 1983 date code, so it is quite old. But yes, capacitors, electrolytic capacitors, do have a finite life, but that life is generally a condition of two things: hours and heat. So those two things is what will determine the life of a capacitor. So just because it's old, it doesn't automatically mean that it needs to be replaced, which is why we can test it. So I've got my Peak Esr Tester here, and Esr 0.1, capacitance 12,000 microfarads, so the capacitance is what you would expect. Now these testers come with one of these tables. Now the problem is that really the value depends, it varies from capacitor to capacitor because they're manufactured differently. So the table is just a generalization. So the only way to get an exact number is off the manufacturer's data, and this is a capacitor that was made in 1983, so I'm not even going to bother looking. But this is good enough anyway to tell me whether this capacitor has gone to heaven or is on the way to heaven, and this indicates to me that it's not. If I saw a reading of several ohms, then I'd start to be worried, but this looks just fine. So I'm quite happy with that, and now I'll move on and test the other ones. Okay, so here's the deal. It's just impossible to work on those caps with the board in position. So the board's going to have to come out, which I'm hoping won't be as hard as it looks at first glance. So there's stuff on the rear panel that makes the board unable to come out, but the rear panel itself comes off. So basically there's all of these screws around here, around the edge, and then there's one screw here which is a bit different to the others. It's got a internal star washer on it. It's a little bit longer. And also the top two screws only of the fan, not the bottom screws, so I need to tighten that one up again. These top two go into the heatsink. So that then makes the rear panel free. Now it's held on the right side by the GPIB board, but that's just a ribbon cable, so I can just pull that out. And yeah, look at that. So now that's totally out of the way. So that means that I can now access these. This screw here was underneath the IEC connector, so I couldn't access that. And yeah, the heatsink is screwed onto the board, which I was a little bit worried about, as to whether I was going to have to undo some of this stuff on the heatsink, which I am not. So that is good. There's a connector here for the fan, so that will come off. Then I can probably just swing this thing around the side when I do that. So I'm just going to tighten up that bottom screw for the fan that I loosened, and also this earth will have to come off as well to swing the thing out of the way. But that's the general plan. So that's the fan connector there, which I'm about to yank out. It is AC, so the polarity won't matter, but it's always good practice to put things back in the way they came. So this is to show me the way around this connector goes. So now that that's nicely out of the way, I can get a much clearer view as to what's going on. So I just want to have a good think about this before I dive into this, because so all of these transistors I can unplug, but the power transistors, which are down here, they are hardwired. So that's this ribbon cable here, which goes over to the high power slot, which is this one here. So so I won't be able to unplug that, but that probably doesn't matter because I can make a little work surface to work on up here, as long as the board is out and I can access it. So those can all come undone, and this cable over here will come undone, and this is the voltage rails, 8 volts, ground, what's that one, minus 26 I think it is, and plus 26. So the order of, I'll just start unplugging these now. So this one here, note the cable is around this way, with the brown on the left hand side and orange on the right hand side. And then with these power connectors, 8 volts is red, ground is black, minus 26 is purple, and plus 26 is red. So that's those undone. And I'll just leave these in for now until I get the screws out. So I'm not going to be able to fold this board up because there are still some connections down here on the underside, power connections, and so they are preventing me from lifting the board up, and I don't really want to take them out. However, now that the board is free, I do have enough movement that those capacitors that previously were covered up, that's these ones here, so hopefully I've now got enough access to be able to get to those. So that being the case, hopefully I don't need to go any further than this. So I've got these metal can electrolytics out, which wasn't as easy as I'd hoped because these big copper lands, they're on the power supply rails. This has a switching power supply. So these are pretty good quality capacitors. So I had to do the old wiggle trick of, heating up a leg and wiggling it out was the only way to get them out. And then I've had to use the sucker on one side and the iron on the other side to clear the holes out. So I've got the holes cleared out so I can put them back in. Now I have put the 2 main filter capacitors back in. One of them did test a little bit higher than the other one, so I got a reading of 0.1 and 0.04. So I think they're still both fine, but whether that indicates that maybe one of them is starting to get towards the end of its life, I'm not too sure. You might like to make some comments down below. Don't just say replace them anyway, give some reasons. But for now, I think I'm happy to go with them. And so this is looking around, if I come around here, this is looking at the back side of the board. These land patterns here where those were. So anyway, I have pulled all of those metal can ones out, and this one here it's dead basically. So it certainly was the right decision to pull these out and test them before putting power on this unit, because this one's essentially a DC short, which I'm sure it wouldn't have liked. The other 3 are all okay, but since I'm going to have to replace one of them, it'll look a bit funny with one replaced and the other 3 not. So I'm going to replace all 4 of these. The other ones, the bigger ones like these all test fine. So there's a couple of these 11,000 mic 12 volt, and then there's 3 of those, and then there's these 1600 mic 50 volts. There's 2 of those. So I'm happy enough to put those back in. And there's also some smaller ones that I'm yet to test, so I'll test those soon. So I've checked all of these transistors. These ones here, these connectors just come off. I did do it on camera, but I forgot to turn the microphone on, so that video didn't turn out, unfortunately. But anyway, I've tested them. These ones are okay. There's two down this side that are easy to get to. The two power ones to poke the leads sort of in through here and trying to get onto the back of them. So all of them are fine. Just wanted to make sure that none of them were totally dead. The HFEs are a little bit interesting in that the NPNs have a much lower gain than the PMPs. So when I started, I thought, that doesn't seem right. And I started with the power ones. So the PMP has a gain of 233 and the NPN's gain is 67. I thought that's a bit odd. So then I did these ones as well and I found the same thing. So this one here gains 316, this one's 14, 278, 14, 318, 19, 278, and this one's 39. So all of the NPNs for some reason seem to have much lower gain. I haven't checked the specs on what it's supposed to be, but anyway, the main thing that I wanted to check was that none of these had died altogether, because if they had, they can blow things up. So I suspect that they're probably going to be okay. So what I do know at this stage is that I need to get 4 of these, and I've already got the fuse in that I needed because I didn't have the right value fuse. So I'm going to order 4 of these capacitors, and hopefully that will allow me to get this thing back together, and I'm reasonably confident that it will more or less do the right thing when we do that. Okay guys, it's been over a week since I've had a chance to look at this thing. I was away for a few days, also had to wait for these capacitors to come in. But here they are from DigiKey. So these are Nichicons. They are 390 mic. They are 80 volts, so they're quite a bit higher in voltage than they need to be. It was mainly driven by just what was available in terms of case sizes. So here's the old one here, and you can see that it is the same diameter, and it needs to be because they're pretty close to one another. So I need to make sure that it fits. They're slightly shorter. So these are UPM. That's the full part number there, full manufacturer part number from Nichicon. And so this is a nicely spec'd part. So I selected it based on case size, as I said, but also other specifications, ripple current and so on. The ripple current for the 80 volt part is quite a bit higher, but I didn't specifically go for the 80 volt part because it's 80 volt part. As I said, it's just case size. So I need to get these guys installed. Now, I mentioned earlier just the amount of copper on these things. It's quite difficult to get these holes cleared out, and so there's still a little bit of solder trapped in these. So what I could do is I could do the trick of the soldering iron on one side and the solder sucker on the other side. That would work. But there's another little trick which I'm going to try. I've got the conical tip on at the moment. This might be better with the chisel tip, but we'll give it a go anyway. Basically what we're going to do, might just have to reposition so you guys can see. This is all a bit tricky. Okay, let's see if that'll work. So basically what I'm going to do is see, you've got the lead here. I'm going to heat up the lead, and that will cause the solder to go molten. And as long as I'm moving it whilst it's molten, then it'll leave a little channel for the lead. It doesn't matter if I don't remove the solder, because, yeah, there we go. So it's a little bit tight, but that doesn't matter. The point is that I can get it in there. So that one, I couldn't get it in there before. Now I can. This one here, it's not going to go in. Do the same thing. Come back to that one. That one's okay. Okay, so it's just this one up here. Oh, bend the lead. I'm going to have to change to the chisel tip, I think, for these last two. Okay, let's give this a go with the chisel tip. It's just that there's so much copper hanging off these. It's just trying to get enough heat into it. Because the other problem is that I can't really see, whether the chisel's flat or not to get the heat into the work. Not having any luck on that one. We'll give this one a go. No, it's not going to work. So I'll have to go back to the other plan, which means I need to access both sides of the board. So I'll get this thing rolled over and give that a go. Okay, so I can see the bobber solder I'm trying to get is right there, so I'm just going to give it a go with the braid and see whether that will work. And I think that did work. Yes, it did. Now, where was the other one? Was it this one? Oh gosh, that one's still not right. Won't go through. That's what I'm talking about, but there's still so much solder in there that I can't get it out. Alright. I think we're going to have to go back to the old trick of iron on the other side. Now you can see why I'd really like to have a proper solder sucker. Okay, I got the first one off camera. And this should hopefully be the last one. So doing it this way, I might have mentioned it before, but I'm doing it with the conical tip because the tip is small enough to actually poke through the hole. So I'm coming in like this, poking the tip right through the hole until it goes molten, then just sucking the solder out that way. But you do need to be able to access both sides of the board. So hopefully these are all clear now, so if we can get these capacitors in. Okay, so we need to make sure we get our polarity right. So there's two sets of them that are in parallel. So this one's in parallel with this one, this one's in parallel with this one, but the polarities are on the opposite way. So there's a plus there, and then there's a plus there. So that's the plus 24 volt rail, and that's the minus 24 volt rail. So let's do this one first. Plus that way. Okay, just give the leads on the other side just a bit of a bend so it doesn't fall out. Then is mate the same way. That's the idea. And the other two, so pluses towards us, which means minuses away from us. That one. These leads are a little bit bent. There we go. Last one, pluses there. That's it. Okay, so I'll need to swing it as chassis around again so I can get to the bottom with the soldering on. We'll just tack in one leg of each capacitor and make sure they're all seated nicely before we do our final soldering. Okay, I know this Maggie lamp flickers on the camera, but I cannot see without it. I'm going to try this first of all with the conical tip because it allows me to get in at this angle, which actually allows a good application of heat, so that works quite nicely. Let's try this one. Yep, it's worked lovely. This guy. Getting a big blob running down the tip, which we don't really want. No. Problem is I can't get the solder in at the right angle. So what I'm going to do is I'm going to do these bottom two. Just make sure it's sitting flush on the board, which they are. do these bottom two, which means then I can cut the leads off. There we go. This one. Now, with those leads clear, we can better access these guys. This one's probably going to be a bit easier because there's less copper hanging off it. That looks good. And this one here. Again, I just need to make sure that it's sitting flush against the board. Here's mate. Yeah, they weren't quite flush. That's better. Yeah, a lot of heat needed for that one. Now this one, it's kind of hiding behind this bracket. That's better. So just trim these leads off. Put a little bit of liquid flux on these. I'm just going to reflow these all just to make sure I have a nice clean joint. That's what I want to see. Basically see the whole joint reflowing, getting nice and wet with the heat. This is the hardest one here, but yeah, lovely. I'll just give it a bit of a clean up. Go away, bit of solder. Oh gosh, come on, gotcha. Okay. So, fingers crossed, that's all good now. As I mentioned, the only problem that I found was that one shorted capacitor. So, I'll stop that flickering. I know it's annoying, sorry about that, but I need to be able to see, otherwise I can't do anything. So, yeah, I found that one shorted capacitor. All the other ones checked out okay. So fingers crossed, that's all that needs to be done to this. So I'm just going to have a really good sanity check, because as I mentioned, I've been away for about a week, and when you leave things aside and come back to them, there's always a risk of losing focus and so on. So I'll have a close check now, and if it all looks good, then I'll put this unit back together. Okay guys, she's all back together. So fingers crossed. So I've got the dim bulb tester on. So firstly, that's expected because power is off. Now we'll turn power on the front of the unit. Now dim bulb tester. Oh, that's encouraging. I didn't hear any bang. I don't see any smoke. I didn't hear any. I don't smell any smells. So I'm not going to go poking my fingers around there because there's very high voltage on those capacitors. But I can measure the voltage rails. So that's what I'll do next. Okay. So I am just leaving it through the dim bulb tester for now. Because it seemed happy enough. So I think this is supposed to be +8. Something is not right. It's 24. The voltages come and go, and then you can see on the dim bulb tester, see how the power consumption is kind of cycling? It's going up and down. Now, it might be that it's detecting the mains voltage is falling when it tries to start the power supplies. I'll just turn that off. I'm just guessing here, I don't know for sure. But it might be the case. So I just need to have a bit of a think about that and see what I'm comfortable with. So I decided that since nothing catastrophic happened with the dim bulb tester, it's not pulling massive amounts of power. So I've taken the dim bulb tester out and I'm just going to see what happens now. That's better. 8.2 volts. Stable. -25. Stable. +25. Stable. So that is encouraging. Now, there are various calibration procedures in the service manual. However, I'll just turn this off. They require kind of like a dummy load arrangement, which I do not have. There's a YouTube video on of another guy who got one of these and did make the dummy load arrangement. From memory, I believe that was to repair a faulty unit. Now, this unit was sold as supposedly working, even though I had a shorted electrolytic in it. So the point is, I don't have that gear to be able to do that proper alignment on it, but the voltages are there, which is really encouraging. Another way that I've seen of being able to test these is basically with a power module. Now, as I mentioned, I bought this to build up a range of test equipment for my laboratory, so I didn't have a mainframe, didn't have any plugins. However, what has turned up is I have this. Let's put that up there so you can see it. So this is a PS501 Power Supply. And so this will generate plus 5 volts and it'll generate 0 to 20 volts. And obviously if there's something fairly catastrophic with this mainframe, then it's not going to work. Now again, this is a plug-in that came from eBay. I'm not too sure of its pedigree, but if I pull this lid off, we can see that there's not a huge amount inside of it. In fact, it's very, very simple. So what I'm inclined to do that will enable me to use this as a bit of a test for this mainframe, I'm just going to check these capacitors here. Apart from that, there's not really very much inside of this thing. So yeah, I'm just going to check these electrolytics to make sure that they look kind of all right. And if they do, then I think I'll be happy enough to plug this in and see whether we get the right kind of voltages out of this module that we should. If we do, then that will give me a level of confidence that this mainframe is good. Okay, so these things are a bit of an interesting arrangement. They're Pcb Mount Capacitors and they're just mounted in this plastic bracket. Then they've just got kind of heavy wire running down to the PCB. So anyway, I know these things are in circuit, but you can still get a pretty good idea. 4,500, yep, that looks pretty good. 0.04, that seems okay to me. And then this one. Yeah, again, that seems pretty good. Just to get this clipped on properly, I was just holding it on. Yep, I'm happy with that. So I'll just get things swung around here and we'll go then for our moment of truth. Okay, so we're plugged in. I'm on the variable output. This should give me 12 volts. The output is turned on, so if I just turn the unit on straight away. Look at that, 12.2 volts, and there should be 5 volts coming out of here. 4.98, pretty good. Has a current limit as well, which I hadn't noticed. That's nice. And if I turn the output off, output goes away, output on, and then press that, it should drop down to 2 volts. And then here's my little voltage control here. Should be about 3 volts here. That's pretty good actually. Oh, look at that. So if I set it to 5, if I press this, it should be 15. Seems to lose a little bit of accuracy. That's supposed to add 10 volts, so it should be 15.02. It goes to 15.26, don't know why. But anyway, I don't think I'll be putting too much effort into this plug-in. I might one day as an exercise, you never know, but it looks like it's basically doing all that it needs to for my purposes. If we go all the way up, there we go, 20.27. Which is what it's supposed to do. We go all the way down here. .25, 0.0 volts. So yeah, there's a bit of an offset between the two ranges, which I might look at one day. But yeah, probably 12 volts I guess is probably a voltage one might want to have. And 5 volts there, still got our 5 volts. Nice. So I might just change over to the alligator leads on the meter, and then I need to test this in the other slots, make sure all the other slots work. This is slot number 2, so we'll test the other slots as well. Okay, I've just switched over to the Keithley, which I know you guys can't see, but it's a whole lot easier for me to use. So we're just going to test these slots. Slot number 1, 12 volts. I'm guessing if the 12 volts is there, we're going to have the 5. Yes, we do. And I'm guessing one is probably supposed to turn the unit off when changing modules. What am I doing wrong? Oh, okay, I see. It goes over it like that. Okay. Slot number 3, 12 volts. Yeah, that fan is kind of noisy. I know some people change over to a quieter fan. I might one day. But you know, I don't expect I'm going to be using this thing a huge amount, which is why I didn't want to spend too much money on it. Not that I have a choice, as I mentioned, when you pay the freight to Australia. 12 volts, correct. 5 volts. Volts. I know I didn't check the 5 volts on every slot, but there we go. Okay, now this last slot is the high power slot. Oops. .12 volts. Okay, so look, I know it's, you know, according to the service manual, it's not a definitive test or calibration that I've done. It just gives me a level of confidence, which is what I'm looking for at this stage, that there's nothing catastrophically wrong with this unit apparently. There was that shorted capacitor, as we've mentioned, that we've repaired. So I'm hoping that now if I go and get some additional modules, so I want to get a function generator module, and what I'm seeing just looking at what's available on eBay is that most of the modules, the freight is just as much as the module. So, you know, you're looking $100 Australian in freight for a function generator module, and they're not, the modules themselves are not especially expensive. So what I'm seeing is there's a few of the FG5010s, which is like the digital programmable one that only works in these 5000 mainframes. It won't work in the 500 series. But when you factor into the freight, it's only an extra $50 to get a 5010 instead of like one of the older 500 series function generators. So we'll see what's available, we'll see what I end up getting, but that's the direction that I'm heading. So anyway, I want to get the covers back on this thing now, and I'll see if we can get it set up on my test trolley. Okay guys, here we are. So I've got everything set up on my test trolley. I'm very, very pleased with this. Everything actually fits. So here's my new to me mainframe with its PS501-1 power module. There's my Keithley 2015 THD, which is measuring the 5 volts. And up here is my Tektronix 2247A oscilloscope. It's measuring the 12 volts, giving me a nice reading using the measure function on this lovely Tektronix analog scope. So every item on this bench has actually come from eBay. So I'm very pleased with this. Getting some decent test gear. I mean, I know some of this is old. The mainframe is the oldest thing. The power module goes back to the 1970s, but it's nice gear and it does a good job. So, you know, there's nothing wrong with that at all. So I'm very, very pleased. I hope you enjoyed this video. Please do subscribe to my channel. Leave a comment down below if you did subscribe, and I'll make sure to say g'day to you. And please give me a thumbs up, and I look forward to seeing you on the next video. Bye for now.